here the given data is, so the speed of 10 HP to 10 volts 1000 rpm separately excited DC motor is controlled by a single phase converter. So this is a single phase converter and our given data is 10 HP to 10 volts 1000 rpm. The rated motor armature current is 30 amps. Okay, armature current is 30 amps and the armature resistance is RA is equals to 0.25. AC supply voltage is 230 volts. So AC supply voltage is 230 volts. Then the motor voltage constant is Ka5. So voltage constant here is given as Ka5 is equals to 0.172 volt per rpm. Assume the sufficient inductance is present in the armature circuit. So they are saying we should assume the inductance is there to make the motor current continuous and ripple free for a firing angle of. So firing angle is also given as 45 degrees, right? Then and rated armature current and rated motor armature current. Determine the motor torque, speed of motor at rated armature current. Okay. So the first bit, in the given data they gave IARA, voltage, KAF constant and firing angle. So for this given data, first A bit, they are asking us to find the torque. So usually TL is equals to KFI IA. This is the formula. So KFI is given as how much is KFI given? 0.172 volt per rpm, right? So this is already given. So now KA is 0.172 and our IA armature current is given as 30. Okay, armature current is given as 30. Okay, but here what is it given? KFI is given as volt per rpm, but we should convert it into volt per second, right? So volt per second, I'm converting it as 0.172 times 60 by 2 pi. So times 30 will be there only. So now this will be 1.6. So 1.64 times 30 is given as 49.2 Newton meter. Okay, next B. So B, they are asking us to find the armature voltage. Armature voltage where in fully controlled single phase converter. So this is the B. So when they want us to find the armature for voltage fully controlled single phase converter, our formula is EA is equals to EM by pi 2 EM by pi cos alpha, because it is fully, so it will become 2 EM by pi cos alpha. EM is given as, so EM is given as 230 in two phase. So root 3 times 230 divided by pi cos alpha is given as 45 degrees. So if you use calculator, you will get 146.42. Okay, and EB we know EB is equals to NKA5, but here I want N, so N is equals to EB by KA5, but EB is given as EM minus IARA divided by KA5. How come? Because EA is equals to EB plus IARA. So I want EB, so EB is equals to EA minus IARA. That's what I did. Already EA, we calculated it as 146.42 minus IA. IA is given as 30 in our given data, like how we used IA as 30. Okay, so IA is 30 and RA is given as RA is 0.25, so I'm using 0.25 divided by KA5, it is 0.172. So if you use the calculator, you will get 807.67 rpm. So therefore The speed is 807.67 rpm, right? So this is our second one. So to find the load torque, we have Ka phi Ia. Ka, we should convert it into Ka phi. We should convert it into what we say seconds. So that's why I converted. Then we got our TL. Then armature voltage in fully controlled. Fully controlled formula is this. So I used this formula to find EA. EB is equals to N because our target is to find N. So I used this formula is B is equals to N KFI. So I can write N as EB by KFI, but EB can be written as EA by IARA. EA we calculated, IA is given, RA is given, KFI is given, so easily to calculate N. So this is how we found our load torque and EN.